Hey everybody, I wanted to spend a little bit of time and go over some problems for the some concepts for the test. And in this case, we're going to go over question 16.4 here. And I'm going to be that guy where I'm not going to give you the questions exactly to look at, but I'm going to make sure that I review all of the major topics. That way you have something to at least look at, and then kind of know the concepts, because the concepts are important. Now, I'm sure that at some point I'm going to ask you to calculate a pH or a pOH or something like that. And so here we have a probe that's in this beaker, and we're told that it's a beaker is either HCl or KOH. Now, which one is it? Okay, well, I would say that it's got to be KOH, because the pH here is 12.08. Any strong acid or strong base, any strong base has a pH above 7. Any strong acid has a pH below 7. Okay, so just looking at this, we can tell that the pH, because of the pH, it must be KOH. Okay, now we can, we can determine its molarity because we have its pH, but we have to do something a little bit more kind of exciting here. So let me bring up my calculator. And so when we do this thing, we gotta go and we gotta, okay, so we have a pH equal to 12.08, and we want to find the concentration of KOH. We want to find its molarity. Well, keep in mind that for a strong base, the concentration of hydroxide ion will equal the concentration of KOH, because strong bases completely ionize. So all the KOH will turn into hydroxide ion. So knowing that, now what we can do is we can calculate the concentration of the hydroxide ion. Well, how do we do that? Well, we need to find the pOH. And so the pOH equals 14 minus pH. And so that's going to be 14 minus 12.08. And so the pOH in this case equals 1.92. Now, that's not the concentration, though. Remember that pOH equals negative log of the concentration of the hydroxide ion. Well, now we have to do some math, okay? And so when we do the math, we get, let's see, 1.92 equals the negative log of the concentration of the hydroxide ion, okay? And then let's see, so how do we delog this? Okay, so we're going to take the negative over here, so it's negative 1.92 equals the log of the concentration of the hydroxide ion. Whoops, put it on the outside instead of the inside here. Okay, and then we delog this by going 10 to the, that gets rid of the log. And so now what we get is 10 to the negative 1.92, and that is going to give us the concentration of the hydroxide ion. Okay, so that's 0.012. That is the concentration of the hydroxide ion, which happens to equal also the concentration of potassium hydroxide, because for every one hydroxide ion, you only have one potassium hydroxide. Okay, now the last part says, why is temperature given on the pH meter? Okay, well, this is an equilibrium question. Okay, what is the only thing that affects the equilibrium constant? The only thing that affects the equilibrium constant is temperature. So now if we are thinking about equilibrium constants here, okay, well, we know that Kw equals the concentration of the hydroxide ion at the times the concentration of the hydronium ion. Well, this is part C of that question. So the point is that at different temperatures, this thing is going to increase or decrease slightly from its given value of 10 to the minus 14. So if that's going to increase or decrease slightly from its value at 25 degrees, then we need to know the temperature so that we can recalculate what it is. Now, in this class, I will tell you that we don't consider changes in the temperature when we do our pH. We just assume that it's close enough to the 25 degrees C that we don't have to worry about that. But it's still important to realize the temperature does affect the pH slightly because it affects the equilibrium constant of water. Okay, so that's question 16.4.